So I want to start just by demonstrating the force diagram. So I've taken the diagram of the situation with the pulley, and it's put all the key information that we need to demonstrate the forces acting on particle B and on particle A. Now we're told that A is on a rough surface, a rough table, and there's a frictional force, 0.5 G, which is opposing that. So its motion is going to be to the right, and the 0.5 G is acting to the left. Again, some key things: the tension, this point here and this point here, they're going to be equal, and the acceleration on both of the particles will be equal. Which then brings us to the first question, is to find the acceleration, which typically leads us into the question where we're going to have to write down equations of motion for A and for B. Okay, so if I take particle A and particle 8, I'm going to resolve to the right. So we've got T minus 0.5 G is equal to mass times acceleration. Well, the mass of the particle is 2.8, so it's going to be 2.8 A. And then the force equation for B, I'm going to resolve that downwards in the positive direction. That's going to be 1.6 G minus T is equal to mass times acceleration, so 1.6 A. So I've got negative T here, positive T here, so we would typically add the two equations together. That's going to give me 1.1 G is equal to 4.4 A. So the acceleration is 1.1 G over 4.4. I see that as a quarter G, so it's going to be a quarter G meters per second squared. Now I could evaluate that and then give the answer at either 3 significant figures or 2 significant figures. So part B, we're asked to find the time it takes for the particle B to reach the floor. Now in this setup we have constant acceleration, so I can use the Suvat equations. So SUVAT, so I'll just plug in what I know. So I know the particle will have displaced 0.7, its initial velocity of 0. When we've discovered what the acceleration was, 2.45, and we're trying to find t. So let's use S equals ut plus half at squared. Just rearrange that. So I've got 1.4 divided by 2.45, square root that, and that gives us the time. So t is equal to 0.756 seconds with 3 significant figures, or t is equal to 0.76 to 2 significant figures. Okay, part C. So we're being asked to find the total distance travelled by A before it first comes to rest. So A is undertaking essentially 2 forms of motion. The first motion is when the string is taut and we've got constant acceleration. And then once B hits the ground, the pulley system becomes slack, and A is then only being acted on by a single force, which is the 0.5 G, i.e. the force of friction. So there's 2 key questions I need to establish. I want to find the final velocity as B hits the ground, and then the new acceleration after this event. So that's the event when the string becomes slack. Once I know this final velocity and the new acceleration, I can then set up a new Suvat equation because it's a new constant acceleration situation. So let's just have a look at that first case. So SUVAT, I know S is 0.7, U is 0. This is what I want to find, 2.45. So I can then just substitute that into my equation. So V is going to be equal to 2 times 2.45 times 0.7, and that gives us 7 and root 7 over 10, or 1.852 meters per second. Okay, so I'm just going to collect that together to put that to one side. So I've got my final velocity as B hits the ground, which will ultimately become the initial velocity for the new situation. Let's just find the acceleration for the new situation. So once B hits the ground, the string becomes slack and tension goes to 0. So my new force diagram would look something like this. So that's going to be 0 newtons in that direction. And we still got 0.5 G newtons opposing that. So I know it's going to be decelerating, but I like just to choose the direction of travel as being the positive direction. Kind of resolve to the right, i.e. for me it's resolving in the positive direction of motion. So I've got 0 minus 0.5 G is equal to the mass of that particle, which is 2.8 times acceleration. So A is going to be minus 0.5 G over 2.8, and that comes to minus 1.75 meters per second squared. Okay, so I've got everything I need now. Let me just rearrange that, put it to one side. Now we can focus on this new situation, this new constant acceleration situation. So my new Suvat equations are going to be, well, I'm looking to try and find the displacement. The initial velocity is going to be 1.852, and the dots there represent that I'm going to use the exact number that I got from my calculator. Set that equal to 0, and the acceleration minus 1.75. So again, I'm going to use v squared equals u squared plus 2as and substitute what I need into there. So I've got 0 is equal to 1.852 squared plus 2 times minus 1.75 times s. So if I just rearrange that equation now, so I've got 1.852 squared divided by 2 times 1.75, and that should equal the displacement. I'll just give you a moment to think about that. Perhaps you could just pause the video to see what I've done. And that gives me 0.98 meters. So, but we are asked for the total distance traveled by A before it first comes to rest. So I have to take into account those two motions. So first of all, it was pulled along 0.7 meters as B dropped to the floor 0.7, and then it decelerated at a distance of 0.98. So that gives us a combined total of 1.68 meters.